Okay, in this short video I'm going to go over concepts and problems from sections 12.1 to 12.3, which is our first look at statistics. So first we're going to look at sampling techniques and some misuses of statistics. So what are statistics? A lot of different definitions. It's the art and science of gathering, analyzing, and making inferences, that's predictions, from numerical information. It could also be non-numerical, your book focuses on numerical, obtained in an experiment. And there's two main branches: descriptive statistics, which is concerned with collection, organization, and analysis, and then inferential, where we try to make generalizations or predictions from the data that we collected. And statisticians' interest lies in drawing conclusions about possible outcomes through observations of only a few particular events. The population consists of all the items that we're interested in, or all the people that we're interested in. And the sample includes some of the items in the population. We're going to talk about the types of sampling that we can use. A random sample occurs if the sample is drawn in such a way that each time an item is selected, every item or every sample has an equal chance of being drawn. When a sample is obtained by selecting a random starting point and then selecting every nth item, it's called a systematic sample. A cluster sample is sometimes referred to as an area or geographic sample, and essentially the sampling consists of a random selection of groups of units, and it's thought that each cluster or group is similar to the whole population. Stratified sample involves dividing the population by characteristics so that each stratum has a common characteristic. So we could talk about gender, race, religion, and we could divide the population by male, female, religion, political affiliation, and then we take a random sample within each of the stratum. Convenient sampling uses data that are easily or readily available, and it can be very biased. And a census is when we collect or enumerate every member of the population. And in the United States we call it a decennial census. It's done every 10 years. The next one in the United States will be in 2020. An attempted census is used when we try to contact every member of the population, but we don't actually get data from every member. So let's try a couple examples where we're going to identify the sampling technique. Every 20th soup can coming off of an assembly line is checked for defects. So the key word here is 20th soup can. So this is going to be systematic sampling. A $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin and the tickets are mixed up. The winning ticket is selected by a blindfolded person. So each ticket is equally likely to be selected, so this is a random sample. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. All the children from each selected school are included in the sample. And this would be called cluster sampling. And again, think about the geography that's involved this time. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. This is a convenient sample. We get what's easy to get. The sample is selective data that is easy to obtain. All registered vehicles in the state of California are classified according to type: some compact, mid-size, full-size, etc. A random sample of vehicles is taken from each category. This would be a stratified sample. The second section we're going to cover today is frequency distributions and graphs. And you're not actually going to create the frequency distributions, but you're going to look at interpreting them. So a piece of data is a single response to an experiment, and a frequency distribution is a listing of all the observed values and how frequently they each occur. So for instance, here's a frequency distribution of family income, and we see that 2 people had a family income between $31,500 and $37,600. 3 families had a family income between $50,100 and $56,200. Mode. Now the mode is the most frequent, and in a frequency distribution it's the class with the highest frequency, and in this case it's going to be the 43,9 to 50,000 class. How many families had incomes above 50,000? Above 50,000 is going to be the lower 3, so it's going to be 5 families. Use the histogram to answer the following questions. And the histogram shows us the number of soft drinks purchased at a theater, and we see it goes from 0 to 6. The height of the bars here tell us the frequencies, and notice the bars in a histogram, they touch. How many people were surveyed? In order to determine that, we're going to add up the frequencies of all the bars in the histogram. So we have 3 is 6, and 7 is 13, and 4 would be 17, and 3 would be 20, 22, it looks like 23 altogether. What is the modal class? That's going to be the class with the highest bar, and that's going to be 2, so 2 drinks. How many people bought 4 drinks? So we look here, and we look at the height of the bar, and we see that 3 people bought 4 drinks. How many soft drinks were purchased? In order to do this, we're going to have to add the value of the class times the frequency. So 0 doesn't really help us at all. So we have 1 times 2, plus 2 times 7, plus 3 times 4, plus 4 times 3, plus 5 times 2, plus 6 times 1. And if you add all those up, you get a total of 57 drinks purchased by the people that were in this survey. A frequency polygon is a line graph that scales the same as those of the histogram. The horizontal axis indicates the observed values, and the vertical axis shows the frequency. And instead of having bars, we connect where the top of the bar would be with lines. So this is the one we were looking at with the children per family, and here's the frequency distribution, frequency polygon rather. Use the frequency polygon to answer this question. How many families visited the zoo 4 times? So we look at 4 and we go up here and we see it would be 8 families. How many families visited at least 6 times? So at least 6 would be 6 or more, so we would add 11 plus 9 plus 3 plus 1, and we get a total of 24 families. How many families total were surveyed? We'd have to add up the frequencies across all the heights of the bars that would be on the histogram, and we get a total of 52 families. A stem and leaf display is another display for quantitative data. It groups the data while allowing us to see the actual data values that make up the data. So if you notice here, it looks like a histogram on its side, but we can actually see the individual data values. 20 students in a geology class were asked how many college credits they had earned. The responses are given here. Construct the stem and leaf diagram. So the first thing you have to look at in the data, it's not in order. It would be helpful to put it in ascending order, but we notice there's a 21. And you notice the difference between the stem and leaf on the left and the right. If you notice on the left side, there are 2 26s. Let's look at my data set here. Here's a 26 here, and here's another 26 here. Likewise, I see there's 2 35s, and in my data set there are 2 35s. So the correct stem and leaf, and I actually put it in ascending order here for you, makes it a little easier to see. So 21, 23, 25, 2 26s, a 29, 2 35s, 41, 43, 46. So this is the stem part, the 10s, and then the leaves here are the 1s. And again, we see 2 59s, 2 61. So the correct answer is going to be this stem and leaf on the left side. A circle graph or a pie chart are used to compare parts of one or more components to the whole. 800 people attended a Ringling Brothers and Barnum and Bailey circus, and they were asked to indicate their favorite performance. The circle graph shows the percent of respondents that answered tigers, elephants, acrobats, jugglers, and other. Determine the number of respondents for each category. So they gave us the percents, but they didn't give us the numbers. And we know the total 800 people were asked. So in order to get the number for each category, we're going to multiply it by the percent. So we're going to take tigers would be 38% of 800, etc. And you'll see this on the next slide. So 38% of 800 gives me 304. 26% of 800 gives me 208. And when I work these all out here, they should add up again to the total that I started with of 800 people. So 304 said tigers, 208 said elephants, etc. The cost to attend a public university in a recent year was $14,967. The circle graph shows the percent of that cost for tuition and fees, the blue one, for room, board, room is green, board is white, and computer costs are red. Determine the cost in dollars for each category. So just like we did on the last one, we know the total cost, and we can just multiply each percent. So tuition and fees is going to be 31.2% of $14,967, which comes out to be this number here. And then we're going to do room, which is 39.5% of the total cost, which comes out to be this number. And then the board is going to be 22%, 22.8%. And finally, the computer cost, the lowest, comes out to be that. And the nice thing on a problem like this, again, as I mentioned, we can add those numbers up and make sure we come back to the total cost of the tuition. And then the last section we're covering this week is the measures of central tendency. The average is a number that is representative of a group of data, and there's a lot of different averages that can be used. The mean, the median, the mode, the mid-range. Each one is calculated a little differently and may yield different results for the same set of data. The mean, which we indicate as x bar if we're talking about a sample, is the sum of the data divided by the number of data values, and there's the formula. Where summation of x, this is a little summation symbol, means add all the data values up and then divide by n. And if we're talking about a population, we use the Greek letter mu. So we use x bar if we're calculating from the sample, we use the Greek letter mu if we're calculating from the population. Determine the mean of this set of firefighter ages. So what we're going to do is we're going to add them up, get 190, divide by 5, the average age of the firefighters is 38. The median is the middle value in a set of ranked or ordered data. The mode is the most frequent. So let's take two data sets here and find the median. And I think I'm also going to do the mode. So let's do the median. So I've got 8 pieces of data. They're in order. So the median here is going to be midway between the middle two numbers. So the median here is going to be 13. The mode is the most frequent. And I notice in this data set there are two modes, 11 and 16. So I should mention the mode is the one average for a data set. There may be more than one. There may be none. There may be more than one, or there may be just one. And on this little data set, let's find, we've got 5 now. Now the median is going to be the middle data value. In this case, it's going to be 8. And the mode on this data set is 8 also. The mid-range is the value halfway between the lowest and the highest values in a set of data. So if we go back to the firefighters, we're going to take the lowest value, which was 21, the highest value, which was 51, and take the average of those two. Whoops. And the mid-range for that firefighters would be 36 years. So those are the 3 sections we're covering this week in the statistics module, the last unit in the course. Next week we'll finish up the statistics and then we'll move on to the proctored final exam. So we will chat again next week, and I will have a live chat the following next week, not this coming week, but the week after. So have a great week.